Hello, hi. Myself, Dr. Vinod. I'm working as Associate Professor in Electrical and Electronics Engineering Department in Marri Institute of Technology and Management. Today, I'm going to deal the topic that is star to delta and delta to star transformations. This is with respect to subject basic electrical engineering. Let us start. So for this, first I'm going with the introduction. Introduction is, as we know, like in electrical engineering, the complex resistor or impedance networks generally often appear in the three-phase systems. So among these, that is star and delta configurations are the most common forms of this interconnection. As we know this, understanding how to convert between these two forms is essential for simplifying the circuit analysis. So, the point to be discussed here is how we are analyzing what is the importance of star to delta conversion and delta to star conversion. Delta to star conversion is a key point. So, star to delta and delta to star transformations that allows the equivalent networks to be formed without changing in the behavior of the circuit. So the point is, we are transforming from star to delta and delta to star without changing the behavior of the circuit. This is a fundamental. If at all there is a behavior in the circuit, then this principle is going to be useless. So that's why whatever you are doing, star to delta transformation or delta to star transformation, that has to be done without change the behavior of the circuit. A star connection has three elements connected with common neutral point. As delta we know, connection forms a closed triangular loop with each element connected end to end. Here you find the neutral point. Here you don't see the neutral point. These two networks behave differently but can be converted into one another through standard formulas. So we are converting or doing the transformation of star to delta and from delta to star with standard formulas. And the important point is the behavior circuit must not change. Such transformations are extremely valuable when dealing with unbalanced and unsymmetrical networks. They help eliminate nodes or reduce the complex networks into simple form and solvable form. So this transformation, what are we trying to do? So finally we are reducing the circuit such that we are applying the formulas. Converting a delta load to star load often makes calculations easier by reducing the equivalent impedance. Similarly, we know like star to delta conversion is useful when analyzing networks that do not easily reduce in series and parallel forms. So the point to be discussed here is star and delta conversion. So already we have the basic classical techniques. So whenever the resistance are in series, whenever the resistance are in parallel, then what is necessity of star and delta? Star and delta, generally they solve the complex problems. So whenever they are in series, straight away we have formula. Whenever resistance are series, whenever the resistance are in parallel, we have the formula. But whenever they are connected in star and delta, definitely you have to go with these standard formulas. So these transformations also help during fault analysis in three-phase power circuits. And these are fundamental in study of polyphase power systems and AC circuit theory. So star to delta, delta to star are not limited to common problems or common complex problems, but they are very much applicable to higher level of studies for the electrical engineering. So with these conversions, engineers can predict currents, voltages and power flows more accurately. So another benefit you can see, like simplifying the design of electrical machines and transformer winding. So star to delta, delta to star makes the process easy and it is solvable. So next, the basic introduction is completed. After that we are going with star to delta transformation. If you see here, we have total three resistances, that is Rx, Ry and Rz. For terminal X, we have connected Rx. For terminal Y, we have connected Ry. For terminal Z, we connected Rz. So this is a star form. This is star form. This one is the delta form. If you see here, the same three terminals X, Y, X, Y and Z. The resistor that is connected between the X and Y, we call it as a Rx Y resistance. The resistance that is connected between X and Z, we call it as a RZX. The resistor that is connected between Y and Z, that is called RYZ. So here the figure shows us like this is a star connection, this is the delta connection. So here if you see the Rx plus Ry, this is Rx and Ry. So that gives us Rxy into Ryz plus Rzx divided by Rx, Y, Ryz plus Rzx. This is considered as equation number 1. Next we have Ry plus Rz. So Ryz multiplied by Rzx plus Rxy divided by all the three again, Rxy, Ryz and Rzx. So the denominator will be same for all the three combinations. So this is we have taken as equation 2. Next we are going for equation 3, that is Rx plus Ry completed, Ry plus Rz completed. Next we must go for Rz plus Rx, that is Rz plus Rx is equal to Rzx multiplied by xy plus r yz divided by again the same denominator what you have seen earlier, that is r xy plus r yz plus r zx. So I am equating this equation number 1, subtracting equation number 2, I am going to get rx minus rz. So I am going to get the equation as rx y r zx minus r yz into r zx divided by rxy plus ryz plus rzx. The denominator is same. Why we have got the same denominator? Because the denominator is same for all the values over there in the above equations. So right now I am equating the 3 and 4. I am adding the equation 3 plus equation 4. So from here I am going to get, this is 3, this is 4. If I add, I am going to get 2rx, that is rz plus rx plus rx minus rz. So I am going to cancel rz and rz. I am going to get rx plus rx, that is 2 into rx. The 2 into rx is equal to, after equating we are going to get 2rxy rzx divided by rxy plus ryz plus rzx. So from here I am going to get rx is equal to, if you see the equation, that is rx is equal to rxy rxz divided by rxy plus ryz plus rzx. If you see this equation in this, that is we have the x, y, z combination. So as I am talking about rx, so x will be the combination with y and x will be the combination with the z. So that's why in the numerator we see like rxy multiplied by rxz. The denominator is rxy plus ryz plus rzx. So similarly with ry, again x, y, z, the combination is for y, that is x and z. So the equation will be ry is equal to r y x and r y z. The numerator is ryz and ryx, and the denominator is the same rxy plus ryz plus rzx. So similarly we are going to get the same thing for rz, the same combination of x, y, z, that is zy and zx. So the numerator will be rzy and rzx. The denominator will be rxy plus ryz plus rzx. So next, that is star to delta transformation. So I am multiplying with rx, ry. So I am going to get rx square plus rx z multiplied by ryz divided by rxy algebraic. So similarly we are going to get ryz, that is ryz square ryx rzx divided by algebraic rxy whole square. So similarly we are going to get for rz and rx combination. So that is rzx square ryx rzx square multiplied by ryx multiplied by ryz by algebraic sum of rx square. So by adding these rx, ry plus ry, rz plus rz, rx is equal to rxy, that is ryz into multiplied by rzx multiplied by rxy plus ryz plus rzx divided by algebraic rxy square. So from here rxy, ryz, rzx, rxy, ryz, rzx, rxy plus ryz plus rzx algebraic of rxy square. So if we keep on solving, finally we are going to get, that is ryz is equal to, that is ry plus rz plus ry rz by rx. Similarly, we are going to get rxy as rx plus ry plus rx ry by rz. And similarly, rz is equal, rzx is equal to rz plus rx plus rz rx by ry. If you see this pattern, for a simplification of remembering, I'm talking about here ryz combination. In this ryz combination, definitely there is combination of y plus z plus y into z divided by what is left over x, that is rx. So similarly here, that is rx plus ry plus multiplication of rx ry, left over rz will be the denominator. Similarly for rzx, that is rz plus rx plus multiplication of rz rx, and the leftover is ry. So this is all about the derivation of star to delta transformation. So next, let us see the problem on this transformation. So this is previously asked in the scheme. So determine the input resistance between PQ using star delta transformation. So this is a question here, as a name as figure 2. So here, if you see, the question is, we need to find out the resistance that is between P and Q. So we need to find out the equivalent resistance that is between PQ combination. Okay. So first, so we have to identify what are the star connections or what are the delta connections, and we need to solve it, right? So let us see. So in the given circuit, so we have 6 ohm, 6 ohm and 18 ohm connected between A, B and C are in delta connection. This is 6, 6 and 6. This combination, these are in delta form. Okay. So as they are in delta connected, we need to convert into star connection. Okay. The details are RA. We have like RAB into RAC divided by the algebraic of RAB. Okay. So that is RA is equal to, what is RAB here? RAB is 6, RAC is 18. This is RAB, this is RAC. RAB is 6, RAC is 18. The total is what? 6 plus 6 plus 18, that is 30. So we are going to get 3.6 ohm. Similarly, RB, we are going to get 6 into 6 divided by 30. We are going to get 1.2 ohm. Similarly, RC, that is 6 into 18 divided by 30, that is 3.6 ohm. So if I see this diagram, this entire diagram will be changed like this. This diagram after transformation will be changing like this. That is 5, 3.6, 1.2, 3.6. Before we have here delta combination. Right now this delta combination is turned to star. Okay, so these values are here. This is one is 3.6, 1.2, another one is 3.6. 1.2, 3.6 and 3.6. 3.6, 1.2 and 3.6. 3.6, 1.2 and 3.6. So from this circuit, if you see, 3.6 and 5 are in series. Right now, if I see this, 5 and 3 are in series, right? And 6 ohm and 1.2 ohm are in series. 6 and 1.2 ohm are in series. Next, and 3.6, 18 and 6 ohm are in series. 3.6, these three are in series. Okay, so this circuit will be turned to this form, that is 8.6, 7.2 in parallel with 27.6. So from here we say that is 7.2 and 27.6 ohm are in parallel, as these two are in parallel, which is in series with 8.6 ohm. The net resistance is, that is, as we already we have the formula, that is 8.6 plus the combination is 7.2 into 27.6 divided by 7.2 plus 27.6. So finally we are going to get, that is R PQ is equal to 14.31. So this is a solution we have received. Thank you very much.